Okay, so last video for P7 on solving equations, and this time we're going to look at radical equations. So anything with a root, like a square root, a cube root, fourth root, so on. So radical equation, first step is just like absolute values, we're going to isolate that one radical, and then we are going to raise both sides to the nth power. So when we say nth power, that's going to come from our index, meaning if it's the square root, we square both sides. If it's the cube root, we cube both sides, and so on. Yeah, after we do that, we're just going to have an equation that we're going to solve the resulting equation, and then finally, we again need to check solutions against domain restrictions, and also, so we could create an extraneous root. Okay, sometimes you'll have a solution that actually works, but not with the original equation. So you need to make sure you double check for those by plugging them back in. So first example, we need to isolate our radicals. So I'm going to subtract 3 on both sides. That's going to leave me with the square root of x plus 3 equals x minus 3. And since I have a square root, now I'm going to square both sides. And we need to remember that that's in parentheses. So I end up with x plus 3 equals, and be careful here, x minus 3 squared means x minus 3 times x minus 3. It's going to leave us with x squared minus 6x plus 9. That's after I FOIL that out. Okay, now just like quadratic equations from last section, we need to do solve for 0. So I'm going to get rid of everything on this side. So I have 0, and then this is going to end up as x squared minus 7x plus 6. Okay, you could do quadratic formula. You can also factor here, and if we factored, we'd have x minus 6 and x minus 1. Okay, that would multiply to get a positive 6 and add to get a negative 7. And then, just like last video, we are going to use a zero product property to solve these. So we separate them and solve each one individually. That's going to give us that x is 6 and x is 1. And again, like I said, we need to go back and make sure that it doesn't create any extraneous solutions. So I'm going to plug this in. If I plug in 6 right here, I end up with 9, and the square root of 9 is 3. 3 plus 3 would be 6. So x equals 6 works. We can use that one. We need to check x equals 1 as well. And if I plug in 1 here, what happens, I get 1 and then 1. Well, 1 plus 1 is 4. The square root of 4 is 2, and 2 plus 3 is 1. So this one actually does not work out. We only have one solution, x equals 6. So on these, the big thing is you need to make sure you go back and plug them in to check. Okay, the second example here, again, I'm going to isolate my radical by subtracting 2, which is going to leave me with the square root of 2x minus 1 equals x minus 2. And I go ahead and put that in parentheses because now we're going to square it, which leaves me with 2x minus 1 on this side. And again, remember, this is x minus 2 times x minus 2, which ends up being x squared minus 4x plus 4. And then just like the last problem, we need to subtract 2x and add 1 to both sides so that we can create 0 on one side, which leaves us with x squared minus 6x plus 5, and again you can do quadratic formula, or this is factorable. We'd end up with x minus 5 or x minus 1, which means we get x equals 5 and x equals 1 here. And again, we need to check our solutions. So if I plug in 5, I'd have 2 times 5 minus 1 plus 2 equals 5, and let's see if that works out. So 2 times 5 is going to give us 10. 10 minus 1 is 9. Square root of 9 is 3. 3 plus 2 is 5. So x equals 5 works. And then if I do the other one, which was 1, if I plug in 1 and 1, I get 2 times 1 is 2. Minus 1 is 1. Square root of 1 is 1. Plus 2 is 3. And 3 does not equal 1. So x equals 1 would not work in this case. So we have one solution, x equals 5. Right, and that's it for this video. Big thing to remember is that we need to check for solutions, because a lot of times when you square both sides or cube both sides, you create an extraneous solution, and we don't want to have that because that would be wrong. So we will see you next time in class.